Thank you, Petra, and thank you everybody for coming today. Like she said, I'm going to be sharing my experience that I had last summer at NCAR. So it's a little different than your typical seminar that's like fully research topic focused. So getting into it, well, I'm sure everybody in this room knows what NCAR is. Not everybody may be familiar with what the ASP or the Advanced Study Program is that NCAR hosts. This ASP program is something that NCAR hosts that has the goal of preparing NCAR for the future by fostering the professional development of graduate students and postdoctoral fellows while focusing on emerging areas of science and facilitating interactions between entities like NCAR, universities, and the broader community. The program itself hosts several activities and research avenues geared towards graduate students and postdocs, including the Graduate Visitor Program, the Postdoctoral Fellowship, and the Summer Colloquium Series, which is what I'm going to be sharing details about with you today. So the ASP Colloquium is a 2-week summer school-like structured colloquium series that takes place out in Boulder, Colorado. And it brings together an international group of students, and each year it has a different area of focus. So last year was all about the atmospheric boundary layer, but in the past years, there have been things focused on climate, sub-seasonal to seasonal predictions, all kinds of different areas of focus that happen each different year. So the colloquium consisted of daily research talks given by experts within the field of boundary layer research. Given the scope of boundary layer work, many topics were discussed throughout the 2 weeks. These topics included observations and instrumentation used to sample the boundary layer, many turbulence-related talks, insights into different kinds of boundary layers, and small introductions to different modeling techniques that are used to simulate the boundary layer. A full list of these different topics is here on the left-hand side of your screen. And along with these research talks, there were several professional development opportunities that took place as well. These included a talk about how to prepare good science talks and presentations, an early career roundtable with NCAR scientists, and an implicit bias training and discussion. We were also given tutorials for 3 different models: NCAR's Community Earth System model, the Weather Research and Forecasting model, and the Chemistry Land Surface Atmospheric Soil Slab model. Through these different activities, we were able to immerse ourselves in different focus areas of boundary layer research, learn from and make connections with experts in our field, and we were able to grow our modeling skill set through hands-on experiences with different models. So as a part of the colloquium, we were given about a 10-hour amount of time for researching and conducting a mini research project that utilized one of the models that we had a tutorial over. I decided to use this time to investigate a case for my PhD work that's focused on observations of the PBL down in Houston, Texas from the summer of 2022. In particular, for the mini research project I conducted, I chose a sea breeze case in which our clamps 1 location clearly captured the passage of a sea breeze. And also in the figure on the bottom right, the sea breeze was also captured by radar as well. So it was a really good case that had clear observations of a sea breeze occurring. And I really wanted to do 2 different things with this mini research project. I wanted to first see if I could even simulate the sea breeze passing over the clamps 1 location, but I also wanted to see what differences occur and show up when I use 2 different PBL parameterizations that are commonly used with WRF research studies. So for the remainder of today's talk, I will take you through some of the results from this project. Keep in mind, we were given a little less than 10 hours for this, so this is by no means a full-on research study, but it was a great way to refamiliarize myself with running WRF and also to do a quick test of simulating the sea breeze and look at how 2 different PBL schemes look in simulations. So as a quick reminder, for those who may not know, the sea breeze is a circulation that develops due to temperature differences between the land and sea. This temperature difference creates a pressure gradient force that then leads to onshore flow in the form of a sea breeze. They're really common in the Houston area throughout the summertime, and they can vary in their depth, their timing, and how far inland they penetrate. So a little bit more about the case in question. Like I said, this case occurred in the summer of 2022 on June 8th, and we were able to capture observations of this sea breeze with our Clamps 1 location, which was north of downtown Houston and about 55 miles away from the Gulf of Mexico coastline. In particular, with this mini research project, I compared two different PBL parameterizations, the YSU and the MYNN 2.5. The big differences between, well, there's a lot of differences, but the two highlighted differences between these two, the YSU is a non-local scheme. So in general, they're thought to better represent the larger turbulent eddies that make up the boundary layer and account for deep PBL circulations within the convective boundary layer. The MYNN is a local scheme, and sometimes, or in past literature, local gradients aren't always representative of the processes that extend through the convective boundary layer, but I wanted to see how these two different schemes simulated this specific case. So here, big question, can the WRF simulate our sea breeze? This is our YSU and MYNN simulations here, just our surface temperatures, and we see this diurnal evolution of that daytime heating, and then a little bit of a cooling signature a few hours before. We have sunrise. I'll let it play again. So maybe there's a sea breeze there. We have to look at more. We can't say, yeah, there's a sea breeze just based off of this. So going a little bit further into the simulations themselves and how they compare with the observations. What I'm showing here right now is our Clamps 1 observations for the full diurnal period, with our sea breeze occurring right around 22 UTC. We see a nocturnal low-level jet both in the day before the sea breeze, but also in the overnight period after the sea breeze propagates through. And when we look at our simulations from our WRF simulations, we do see this capturing of the diurnal cycle in both of the simulations. For the non-local scheme, we do have a stronger nocturnal low-level jet showing up compared to our local scheme, but we do have this general diurnal evolution being captured by the simulations. So if we focus in a little closer on the sea breeze itself in these few hours before and after the sea breeze, we do have the WRF simulations showing a similar increase in wind speed after the observed sea breeze time. However, if we focus in on the sea breeze itself, we do not have this shift to the southeasterly direction and onshore flow direction that we would need to confirm that this was in fact a sea breeze being observed. So based off of this, even though we see this increase in the wind speeds, it's not due to a sea breeze. Looking a little bit further into the observations and how they compare with our simulations, our observations indicate a lowering of the PBL height after the sea breeze passage. And in addition to this, we have moist cooling and more moist air mass, which makes sense when you're propagating that marine flow air mass over the area. When we compare this to our WRF simulations, we do not see this characteristic drop in the PBL height. You see a little bit of a PBL drop later on in this time frame, but that is not due to the sea breeze itself. A couple other differences that we see between the two different simulations themselves are that the YSU scheme actually has lower magnitude vertical velocities compared to the local scheme. The thermodynamics appear to be pretty similar just in this quick comparison, but those vertical velocities are a big difference. Looking again at the heights between the YSU and MYNN simulations, we have similar PBL heights around that, what we would expect our sea breeze time to be, and that drop again later in the evening, closer to sunset, but they are obviously quite different in not capturing that sea breeze passage. Looking a little further at the full diurnal evolution, we can see that this PBL height lowering is likely associated with the evening transition and not actually a sea breeze. So again, just further evidence that at least for this specific case, the sea breeze is not being captured as penetrating far enough inland to reach at least the CLAMPS 1 site. So summarizing all of this together, the WRF simulations are likely not capturing the sea breeze propagation to the C1 location. That being said, we do see a slight temperature gradient propagating inland of that cooler air. So it could be that the sea breeze is being simulated and captured, just not making it far enough inland to the C1 location. On top of this, we see that our non-local scheme, the YSU, had greater horizontal winds, weaker vertical mixing, and a slightly deeper PBL daytime height compared to our local scheme that had greater vertical velocities and a slightly deeper overnight PBL heights. A few key takeaways from the ASP program itself. It was a great networking opportunity. It brought together an international group of students, a pretty small cohort, so we were able to really get to know each other, brought us all together in the same place at the same career stage, and we were able to not only network with ourselves, but we were also able to meet professionals within our specific area of focus. This also was a great chance to introduce many different PBL avenues of research and work, some of which I have never necessarily considered before. So it was a great way to learn about different areas within our field. And then our growth in skills, both modeling, but also communication-wise. There was just a lot of different opportunities for that professional development that you don't necessarily get with people specifically within your area of focus. And of course, advice from senior scientists. Like I mentioned, there was an early career roundtable discussion with NCAR scientists, but there were also opportunities after the research talks each day to speak with those who gave the research talks and be able to ask them questions and really make those lasting connections with folks. A little plug for this upcoming year, the 2024 ASP Summer Colloquium Series is integrating atmospheric and social approaches to improve urban air quality. So if that is within your realm of expertise and interest, I highly encourage you to apply to this. It was an awesome experience. It's quick, but it's a great way to meet experts within your field. And those applications for this year are due on March 31st. So you still have a couple weeks to get it all put together and apply to that. And I'd be happy to ask or answer any questions that you may have, whether it's about what I showed here today or just the general experience. And that is it for me.
Do we have any questions in the room or
Maddie?
First of all, that was a lot of awesome work for 10 hours. Did you get to talk to with like the other postdoc or grad students who also did it? Get to like show your work during the summer as well, or was it kind of a you did the process like kind of back to your?
Yeah, no, we were able, so part of this, the very last day of the colloquium, we had 5 minutes to present our research talk. So we were able to share what everybody did, and each person did something different. There were folks who used WRF like what I did, and then there were a good amount of folks who used the other 2 different types of modeling studies or modeling techniques as well. Yeah.
2 questions. The first one, what would you say was the most useful thing that happened during, what was the biggest, had the biggest impact on you? And then the other question was, did you get any feedback from any of the scientists on your research that you did?
I'd say the most useful part of this whole experience was the networking itself. Being able to meet folks within our field that were at my graduate level, but outside of OU was really nice. I was able to meet folks from other parts of the world. that, as well as the early career roundtable that we had with NCAR scientists, we were able to talk through things like the review process, both from writing, but also what it's like when you have a scientist position and what that review process usually looks like. So there were a lot of really great tips that they shared with us in terms of interviewing and preparing yourself for interviews for jobs, things like that. And no, I did not end up having any feedback. It was a very quick succession of talks in only a couple of hours, so we actually didn't receive any sort of feedback. We had time for questions, but they were like pretty basic, quick questions, no formal feedback process.
And it wasn't that you worked with an NCAR scientist on your research who then provide you one-on-one.
No, it was independent. There were folks there if we had questions for actually like applying whatever modeling technique we wanted to use for the project, but as far as actually like building what we wanted to do for our project was solely independent. It was a 3-kilometer horizontal grid spacing.
Do you think that can play a role? Like the model, like so, where there may be processes that are sub 3 kilometers that would be captured to actually get that for us as far as you want, or do you think it's just a shortcoming of the model?
That's a great question. My gut feeling is that if that 3 kilometers is probably too coarse to capture the sea breeze fully in the processes that go into it. This particular case, by the time it made it to clamps 1, it was already relatively close to sunset anyway. So it could just be that it was too diffuse by the time the model propagated it far enough inland. But my gut feeling is that a smaller grid spacing would allow us to capture some of those really fine scale details that are important for the penetration depth inland.
Ask a technical question, actually maybe two. The first one, and did you account for the urban area in any way in your simulations, like for the urban land use? And the second question, it looked like in both cases there was pronounced a time period before before when you observed the sea breeze that the model showed mostly downward motions. If I remember, yeah, those blue blobs. Yeah, I mean that's why it's several for an hour or so, or maybe even more than an hour. Which, at least in the case of environment, do you have any idea of what that could have caused that?
For your first question, no, I did not take into account any urban land surface with these simulations. For the second one, I am not entirely sure what would cause this difference. We do see in our observations pretty long duration updrafts and downdrafts really often, especially at clamps 1. If you look at the observations here, for instance, we have near 21, a really long downdraft. So I'm not sure if this is just a matter of there being a time delay in the simulation compared to what we see with our observations, or if this is just still the convective boundary layer like what we see in our observations, since we didn't simulate the sea breeze at this location, if it's still just that same characteristic, really long and strong updrafts and downdrafts being captured.
The other thing that struck me is that those simulations have at night, it was not on that plot where you on the boundary line plot, then definitely there was a quite significant difference in the boundary line at the time between the observations and the simulations.
Yeah. I did not think through that. I was focused more on the daytime. My guess would be if we're not simulating that the sea breeze made it this far inland, maybe urban effects are having an effect still on this nighttime boundary layer, especially given the little bit of evidence that we have in the overnight period of still warmer temperatures compared to the rest of the surrounding area. That the star in this is our Clamps 1 site. So maybe it's urban effects still being captured.
What time did you start to run? Like how early does your simulation begin? An approximate time.
I believe I started it at 0Z the day before. This is not the full, I gave it spin up time, but I'd have to go back and check because honestly, I do not remember off the top of my head.
Yeah, that overnight coming into the daytime is interesting. I wonder if you can superimpose on
Yeah.
urban effects. As you're saying. It's cool. How do you think, what you kind of took away from this project that you did, kind of impacted how you came back to your PhD work?
That's a good question. Part of the PhD work, we have a set of WAF simulations that we've run. So this gave me some ideas of what to look at in terms of the differences between the PBL schemes and what I may or may not see when I eventually get to the point of looking at those. I'm not to that point yet, but I was kind of surprised, to be honest, to see such a big difference in the vertical velocity magnitudes between these. So it's something to keep in mind as I get to the evaluation of those WAF simulations.